you're all doing well. Today we're gonna talk about metallic bond. First, you have to review ionic bond and covalent bond just to understand the differences between them before we start with metallic bond. If you do so, this lesson is going to be really easy to understand. Just to recap, remember we said that every atom's goal in life is to have a full valence shell. This is because they want to be happy, they want to be satisfied and stable. So they would do anything. And when I say anything, trust me, they would do anything to be satisfied and stable. So if a non-metal and metal help each other to reach to that point, this bonding is called ionic bond. If a non-metal and another non-metal react, this bond is called covalent bond. If two metals react to be stable and to be satisfied, this is called metallic bond. Now let's talk more about the details. So metals have fewer valence electrons to begin with. They always prefer to give away their electrons. When they lose electron, they become more stable and they become positively charged. This means that they have now formed a positive ion. When two metals need to become more stable, they both want to get rid of their valence electrons, but there is no other atoms to come around and pick up the mess and take those extra electrons, right? So they just lose them anyway. Metals atoms give off their electrons no matter what, because they are so desperate to become more stable and more satisfied. And if there are only metals around them, so they need to help each other. So the metal atoms play a kind of ping-pong game with electrons. When one metal spits off its electron, the other catches them, but instead of holding on to them, it spits it right back. So the two metal atoms are passing the electrons back and forth constantly. This is happening so fast and it happens so much that the atoms kind of feeling like they don't have any electrons. So all of the metal atoms end up more stable, and in the process they form another type of bond. These are called metallic bond. Metallic bond is a bond formed by the attraction between positively charged metal ions and the electrons in the middle. Bonding in metal is a result of the metal atoms being so close to one another that their outermost energy levels overlap. This overlapping allows valence electrons to move throughout the metal. Since the electrons are not connected to any atom, they are moving freely, and this allows metals to conduct electric current. So one of the properties of metal is conducting electric current. Another property is that they are really easy to reshape. This is because the electrons swim freely around the metal ions, so the atoms in metals can be rearranged. Focus on the things that are made of metals. Notice that they are very different. Metals are malleable. That means they can be molded into different shapes. Metals are very ductile. This means that they can be stretched into wires. Metals are malleable and ductile because no matter what shape the metal takes, the free floating electrons will conform to that shape. The strong electron attraction will remain, and therefore the structure stays intact. Let's think about it. Cars, bicycles, trains, planes, buildings, cutlery, spectacles, furniture, and endless items can be made from metals. All this because of their malleability and ductility. Malleability is the ability to be hammered into sheets. Ductility is the ability to be drawn into wires. Another property is bending without breaking. When a piece of metal is bent, some of the metal ions are forced closer together. So as you see here, when we hammer a nail, it actually bent without breaking. Here is a question. Why? And how did this happen? Answer this question in the comment section below. And that's it for today, guys. Don't forget to answer the question of self-check, section review, chapter review, and feel free to ask any question regarding the lesson. Goodbye!